Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, so good morning, class. Today we are starting the geometrical progression, right? So let us start now. So in geometrical progressions, okay, which we call as GP, right? So here, what is CP first? So like geometrical progression is defined as a series in which ratio between any two consecutive term is constant throughout the series, right? Okay. So the this constant ratio is also called as the common ratio. Like if A is the first term and R is the common ratio, then GPV can be write as like A, B, C. R in GP if B square is equals to AC. Okay. So if we talk about the general term or the nth term of a GP. Okay, so this will equals to Tn is equals to A R n minus 1, right? So this is the given formula. Now there's no like nth term form and by the this can be given by like Tm by R to the power n minus 1, where m stands for m is equals to total number of terms. Okay. Similarly, this is first, now second. If A1, A2, A3 are in ZP, then we can say R is equals to AK by AP and 1 divided by K minus of P. So this is the second case. So first you can copy this basic terms are related to GP. Okay, copied. So next, this sum of n terms of GP, right? So sum of n terms of a GP. So first n terms of a GP is given by like Sn is equals to a 1 minus r to the power n divided by 1 minus r, which is equals to a minus r Tn 1 minus r, where r is less than 1. Or it can be Sn is equals to a r to the power n minus 1 divided by r minus 1, which is rtn minus a by r minus 1. So here where r is greater than 1. In the last case, Sn is equals to nr. So where r itself equals to 1. Okay. Now, if we talk about the this infinite GP, so for this it becomes S infinity is equals to a divided by 1 minus r. Okay, and r should greater than equals to 1 for infinity. Then S infinity is infinite. Next, this is geometrical mean is there. Geometrical mean, okay, just ZM. Okay, so like if three or more than three terms are in GP, then the all the numbers lying between the first and the last term are called geometrical mean between them. That is, GM between two given quantities A and B is Z, so that A, G, B are in GP. So that that is we can write G by A is equals to B by Z, which is equals to Z square and is equals to AB, right? So this is Z is equals to under root of AB, right? So this is the given formula for the GM. Now like n numbers, this n GMs between two given numbers are given, then we can say, then if in between two numbers a and b we are like inserted this gm g1 g2 up to gn, then a1 G1, G2 to up to GNB will be in ZP. The series consists of n plus 2 terms, and the last term is B, and the first term is A. So we can write n GNs between two given numbers. So R is equals to B by A 1 upon n plus 1. And for the A, it can be AR n plus 2 minus 1 is equals to B. So for Z1, it becomes AR. For Z2, it becomes AR square. Similarly, it goes up to Zn, which is AR to the power n, or it can be V by R also, right? The product of GMs inserted between A and B is equal to the nth power of the single GM between A and B. That is, we can write product of GMs. So it can be product from R equals to 1 to n Z of R, which is G to the power n, where G is equals to under root of AB. Okay. Now there are superpositions of terms in a GP. Like the first, when number of terms be odd, we take three terms as A by R, A and AR. This we have already shown. So five terms may be like A by R square and A by R, AR and AR square. So here we take middle term as A and common ratio as R. And when the number of terms be even like this A by R cube, A by R and AR cube. Or the six terms can be there like A by R5, A by R cube, A by R, AR cube and AR to the power 5. So here we take A by R as the middle term and common ratio as R square. Okay. So I hope you got that. Now there is one term which is called this recurring decimals. So to find the fractional value of a decimal number whose decimal part contains a repetition, whose part contains the repetition of digits, we can use the ZP. So this concept will be more clear by the examples. So let we are going to take example now, like the nth term of GP nth term of GP is 128, and the sum of n and sum of n terms is 255. If its common ratio is 2, common ratio is 2 given. Okay, then we have to find the first term. Then first term is what? So let A be the first term. We are going to assume A be our first term. So we can write here so given this A is the first term, we can write Tn is equals to 128, Sn is equals to 255. So Sn is equals to Rtn minus A divided by R minus A. So it is 255 is equals to 2 into 128 minus A divided by 2 minus 1. So A is become 1. So this is our answer. Next question, if A1, A2, B2, AMs and G1, G2, B2, GMs between two numbers A and B. So then A1 plus A2 divided by Z1, Z2 is equal to what? So we'll solve by the property of AP and GP. A1, A2 is equals to A plus B, and G1 into Z2 is equals to AB. So A1 plus A2 divided by G1, G2 is equals to A plus B divided by AB. So this is the required answer. Next question. Like question is given to us, if x, y, z are in GP and ax is equals to by is equals to cz, then so we will write if x, y, z are in this GP, then y square is equals to xz. So we say we have ax is equals to b to the power y is equals to cz, which is lambda. So x log a is equals to y log b is equals to z log c is equals to log lambda, right? So here it's become x is equals to log lambda by log a, or y is equals to log lambda by log b, and z is equals to log lambda by log c. So here we got log lambda by log b square, which is log lambda by log a to log lambda by log c. So log b whole square is equals to log a into log c, or we can say log b is equals to log c, which is log a is also equals to log of b. But here denominator will be a, here it's a b. Similarly, like it will be b and it will be c. So this is the required answer. Next term is the harmonical progression. Okay. Which is called HP. So HP is defined as the series in which a reciprocal of its terms are in AP. The standard form of a HP is, standard form is 1 by a plus 1 by a plus d plus 1 by a plus 2d to infinite. Okay, so like if ABC are in HP, then B is equals to 2AC by A plus C. Okay, now the next is the general term of HP. So the general term for the HP is given, which is general term of a HP. So general term Tn is equals to 1 upon a plus n minus 1 into d. So like there is no formula and process for finding the sum of the HP, and we know like first ABC are in HP, then A by C is equals to A minus B by B minus C. And the second thing is, if A and B are first two terms of HP, then Tn is equals to 1 divided by 1 by A plus n minus 1 and divided by 1 by B minus 1 by A. Okay. Next, this is harmonical mean is also given. Harmonical mean, which is we called as HM. Okay. So like if three or more than three terms are in HP, then all the numbers lying between the first and the last term are called the harmonic means between them. That is, the harmonic mean between two given quantities A and B is H, so that A, H, B are in HP. Okay, which is 1 by A, 1 by H, and 1 by R in AP. So we can say 1 by H minus 1 by A is equals to 1 by B minus 1 by H. Here it's become H is equals to 2AB by A plus B. Also H is equals to N, which is divided by 1 by A1 plus 1 by A2 goes up to 1 by AN. So it becomes N, and it's here divided by J is equals to 1 to N, 1 divided by A into, sorry, AJ. So this is the harmonic mean of n number n zero non-numbers. So up to A1, A2, A3 to AN, right? Now we are going to take questions like if between 1 and 1 by 31 there are n harmonic means, the ratio, so it's given 1 and 1 by 31 n harmonic means, and the ratio of seventh and a ratio of seventh and n minus 1th term, n minus 1 harmonic means is 9:5. So then value of n is, okay, so the value of m is, so here we apply this 1 plus 7, which is 31 minus 1 upon n plus 1, which is equals to 1 plus n minus 1 and 3n minus 1 by n plus 1. So the ratio is given is equals to 5 by 9, right? So while solving, you will get n plus 211 and 31 n minus 21 is equals to 5 by 9. So here, while solving, you will get n is equals to 14. So this is our answer. So we are taking one more problem, which is like if a2 by a3 divided by a1 a4 is always equals to a2 plus a3 and a1 plus a4. So which is equals to 3 of this a2 minus a3 and a1 minus a4. Then a1 a2 a3 a4 are in. So solutions. So a1 plus a4 and a1 a4, which is equals to a2 plus a3 and a2 a3. So 1 by a4 plus 1 by a1 is always equals to 1 by a3 plus 1 by of a2, or we can say 1 by a4 minus 1 by a3 is equals to 1 by a2 minus 1 by a1. So it equals 3a2 minus a3 divided by a2 a3, which is equals to a1 minus a4 and a1 a4. So we can say 3 into 1 by a3 minus 1 by a2, which is equals to a4 minus of a1. So this is equals to 1 by a2 minus 1 by a1 is equals to 1 by a3 minus 1 by a2. This is also equals to 1 by a4 minus 1 by a3. So clearly we can say 1 by a1, 1 by a2 and 1 by a3 are in AP. Are in AP. Okay. So we are going to wind up this lecture here. Next class, we will start with the relations between AMGM and HM. Okay. And we will take the method of difference, and then we will solve the problems, combined problems of all the concept. Okay. So from next class, we will do that. Okay. So you can copy this first. So here I'm going to wind up this lecture. Okay, so thank you guys.